Right, so hi everyone, welcome to this IEA Wind Task 43 webinar series, seminar on immersive technologies for the wind energy workforce. For those of you who don't know who I am, I'm Sarah Barber. I'm at the Eastern Switzerland University of Applied Sciences, and I co-lead this thing called IEA Wind Task 43. I'm going to explain a bit later what IEA Wind Task 43 is, but basically it's a large international collaboration where we try to align research and industry activities worldwide on the topic of digitalization. It's got about 300 plus participants officially from 9 countries, but actually from about 30 countries worldwide. So this is, if people know me, they know I always present this slide at the beginning. This is just to remind us all to try to use gender-sensitive language today to make everyone feel included, to try to use non-violent communication to keep a constructive conversation, and also to practice active listening to empower people to find solutions themselves. If you like this slide, then you can get it from the website of the European Academy of Wind Energy, and you can use it for free. So the plan today is that the main reason we're here is because we're Arvind here from Oslo Metropolitan University is visiting us at Ost right now because he wants to swim in our lovely lakes and go up our nice mountains. No, because he wants to talk about collaborations, I mean. And he's going to present some of his work on virtual and augmented reality for education and maintenance planning in wind energy. And so the plan changed a little bit compared to my original plan. I don't know if anybody noticed, but we have about half an hour for Arvind to speak and then 15 minutes for questions. And then we have a 1 hour period where we have some presentations. And I actually forgot to check, is Sarah? Oh yeah, Sarah is here. Hello. That was our first presenter. Yeah, hi. So we have these speakers here on the list who are all going to stick to their 10 minutes. And if they don't, I won't have any time to speak at the end. And we've got a 10-minute Q&A. So the idea would be that everybody just goes through and speaks, and then we do all the questions at the end. I also have a little Mentimeter to encourage conversation. And then after that, I've planned in 15 minutes to talk about how we could use some of the stuff we've talked about today for future IEA Wind Task 43 working group. And I'm going to start that off by giving you a very short presentation about what IEA Wind Task 43 is, so that you have a basis for the conversation. And then after that, the people who are here are going to have lots of nice food and drinks, and all the people who are online are going to miss out. So you can stay and join us and watch us eat if you want. But just a general thing, we're going to record this. Except for Marcus's part, which we're going to stop the recording on, and Dara has got the job of remembering to do that, because anyone who knows me knows that I'm bad at remembering. If any other speakers don't want to be recorded, you can still tell us at the beginning of your talk if you want, and then the recording will be on our website and on YouTube. Yeah, that's it. If you've got any questions, just write in the chat. If you're not speaking, just turn off your microphone. Cameras are encouraged so that we can see your smiling faces. Does anyone have any questions before we get started? Right, so I'll pass on to our special guest to tell us everything he knows about immersive technologies. So do you want to, I think you should be able to share your screen. I have to share this now. Okay. Yeah. That'll be the way forward. Okay. I guess that's the easiest way to do it.
Okay, so shall I start?
Yeah.
Yes. Okay, thank you, Sarah, for hosting me, and a very good afternoon. My name is Arvind Keprate, and I'm a professor at Oslo Metropolitan University in the Department of Mechanical, Electrical, and Chemical Engineering. So today, in the next 30 minutes, I'm going to share what I've learned over the past, let's say, 1.5 years about virtual reality, augmented reality, and how we plan to use it for, first of all, educating the future engineers, and also the future plan is that we want to do the technician training, right? And that is the primary purpose for that, is to reduce the human error. So now the contents for today is that first of all, I will talk about industrial metaverse. So a new, let's say, fancy term. So I will introduce you to this concept. What is this? And then within this umbrella term, I will delve deeper into the virtual reality, because as you might have seen, I have used the word virtual reality, augmented reality, mixed reality. So those of you who are working with these kind of technologies, you know the difference. But 1.5 years ago, I did not know that. And that is why I wanted to share this. The first thing, that is reality, virtuality continuum. And then I'll delve deeper into how the virtual reality in particular has evolved over time. And then I will talk a little bit about why I'm using virtual reality and augmented reality, and also the current status. And thereafter, there is a free VR resource that I'll be sharing with you all, guys. And those of you who are here, I have a MetaQuest. Those who want to try, be my guest. And those of you who cannot, I will share this YouTube video with you, where you can have at least the experience of how a wind turbine is looking from inside, right? So if you see, over the past 15 years, I would say 15, or let's go back to a decade, there has been a continuous transition from the real world. In the real world, I say the physical world, to the virtual world, right? So it was in 1970s, approximately 1960s or 70, when computer-aided design came to the picture. And then with the help of simulations, we are doing a lot of virtual testing, right? So the scenario now is that all of these engineering world primarily is moving from the physical to the virtual. So I will be using the terms virtual and digital interchangeably, but and for the purpose of this talk, they are the same. And what are some of the advantages? The advantages that with all of these simulations, you can run what if scenarios. They are, first of all, from the safety perspective, you can do all of these virtual experiments. You can make mistakes. And if I have to talk about sustainability, so in real world, when you compare it to the physical testing and the virtual testing, I can say that virtual testing is much more sustainable, right? There are plenty of reasons for that. So with this thing in mind, I now want to make a little bit of, let's say, dichotomy between what is analog and what is digital, right? So maybe before iPhone came into the picture, 2008, right? Most of the people who were enthusiasts of clicking the physical world, we were doing it through these cameras, right? Which are almost obsolete. And now if we dig deeper into the science, that how was these pictures developed, right? So there was a chemical process to it, right? And all of this is termed that this was an analog data. But now what has happened with the advent and with this, the technology of mobile phones, we are clicking photos. And these are called as digital. So now the primary difference between an analog data and digital data would be, if I have to summarize it, it's basically anything which you can, send over an email, send over, let's say, a multimedia message, that can be categorized as digital, right? So what is happening there? When we click a picture, everything is converted into zeros and one, and then it can easily be replicated. So on the right, I have given this definition that what is a digital data and what is an analog data, right? So for all of, if I now go back here, so this virtual world that is created with the help of this virtual or a digital thread, right? And this digital thread is built with the help of this digital data, right? So now with this thing in context, in the recent 2 years, I would say what has happened. So the primary two companies who have coined this term is called as industrial metaverse. So it's primarily Siemens and NVIDIA. They have joined forces and they have come up with this concept of industrial metaverse. So you can read the definition here, but in short, what they are trying to do is they are trying to mirror the physical world with the digital world, right? And it is only for the industrial world. Now, if you go to the left, you'll see that there is a strong digital foundation. Again, a lot of data, right? On top of it, you have technologies. I will talk about technologies. Some of them are like digital twins, big data, AI, cloud computing networks. And then why do you want to couple them is because you want to optimize the process, right? You want to optimize the process, which means you want to increase your efficiency. And at the end, all of this will be to make our future better, to make it more sustainable, right? So that is the left part of it. Now, what could be the reason of making everything digital? The first reason is definitely that you can have this 24/7 connectivity throughout the world. There are no barriers. If I have, let's say, a digital twin, I will stick to this particular technology for now, digital twin of a wind farm which is located in the North Sea. So I can access it, right? And even one of my colleague who is sitting, let's say, in India, he can also have an access to it. So there are no boundaries attached to it. And the third reason is what I'll talk in more depth is immersive simulations, right? With the help of immersive technology, I can actually visit this digital twin of a wind farm and I can have a look at it, right? And then fourth, as I've already mentioned, that people or the engineers, the managers from around the globe, they can have this connectivity 24/7 across the borders, right? So that is the primary point of making an industrial metaverse. So let's say if your wind farm in North Sea is having some kind of technical problem. So an engineer is in, again, give an example of India, he's sitting over there. So you don't need to fly him to the wind farm. He can operate it, he can visualize it, everything with the help of this digital and offer solution and probably have the technical solution ready without any commute, right? So from the sustainability point of view, you can see that how much carbon footprint is reduced. And that is why people are now favoring these industrial metaverse, right? So with this in context, so these are some of the technologies. And there is actually a white paper which Siemens have released. If you are interested to know more about it, you can just click on this link when Sarah shares this presentation with you, right? So some of the technologies which I'm sure you might have heard about like digital twin, AI is now another common term which everyone is using, not just verbally, but also, this kind of technology like ChatGPT, that is one form of AI. Blockchain still, if you have heard about these crypto mining, blockchain is there, cloud and edge computing, and then 5G networks, IoT, right? And I will be talking a little bit about VR and AR, right? So these are some of the technologies, and so this list is not exhaustive, but in the industrial metaverse context, there is a strong coupling of these technologies that is happening. So I will focus mainly on VR and AR, but before that, one slide about the digital twin, right? So one example which we have in our research group, what we have tried to do is we are trying to create a digital twin of the wind turbines, just like what Sarah's group is doing over here. Right. So here also you can see that out of these technologies, some of the technologies you will see here also, right? All of these sensor data which will form the digital thread, it needs to be stored in some kind of a database, right? So that is where all of these data lakes and databases come into the picture, right? And then, so here you have your user. So my personal use of these digital twin is only for the maintenance purposes. But again, you can for logistic and for supply chain, you can use these digital twins over there, right? So this is currently one of the projects which we are working on, right? So this was just a brief of this, but now I will go back and talk a little bit about virtual reality, augmented reality, and mixed reality, right? So I don't know how many of you know the difference between these terms. So can I make it more interactive, or if you know, yes. So just give it a thumbs up if you can do that, okay, we know the difference. If not, then in the next slide, I'm going to talk about it. And if you don't know, just say no. Okay, so at least one thumbs up is there. Okay, so people know quite a lot about it. So that's good.
Unless one person just press it lots of times. Yeah.
Yeah. Okay, so now the first thing is, again, with the first slide, as I said, that what we're trying to do is we have a real world, right? So just consider a wind turbine, which is out there in the physical world, right? So you can see the real physical world. And on to the right, you create a CAD model, a 3D model, which is completely virtual or digital, which is residing in your laptop, in your desktop, whatever you're using, right? So now, if I go to the extreme right, So this, when you are fully immersed in this virtual environment with the help of these headsets, then that is called as a virtual reality. So in virtual reality, you don't see the real world, right? You are seeing a computer built world. That is a virtual environment. I don't need to explain what the real world is, because that is what we are supposed to experience most of the time. And then in between this region, which I'll just take off. So now, whenever you have an interaction and whenever you can look both the real world and the computer generated world, so that is where this augmented reality or augmented virtuality, I will explain the difference in the next slide, right? So as you can see in this, you can see both the real and the virtual world. So with these new MetaQuest 3S which we have, so you can actually experience both mixed reality and virtual reality with these new glasses. And this mixed reality is, as the name suggests, whenever you can see the real and the virtual world, right? So that is. Now this augmented reality, augment means to add, this English word means to add to something, right? So you are adding something to the physical world. And that is the augmented reality. So let me go to the next slide. So this fancy term or this concept is termed as reality virtuality continuum, right? So to give it a good flavor. So now again, let's delve deeper into this. So you have your physical world onto the left, and you have your virtual, fully immersed virtual world onto the extreme right, right? So that is why these headsets. Now, in between this, you have an augmented reality, augmented virtuality, and this thing is called as a mixed reality. So this concept can be easily explained with these two terms, right? So let's say you have a physical environment and you have a physical surface. So now this is what we are calling as a physical reality, right? Both your environment and your surface means on what you're working on. Let's say it's a whiteboard or a blackboard, right? So if you are working in a traditional classroom on a traditional whiteboard or a blackboard, that would be a real environment, right? So there is nothing added to it. But now let's see what augmented reality is. You are in a physical environment, a physical classroom, but you are teaching with the help of a virtual surface. This virtual surface, what could be? Here you can see smartphones or tablets. So in maintenance planning now, what is happening is that I know companies such as Equinor in Norway, so they have these tablets, and on top of it, whenever you are going into this offshore platforms, oil and gas, so the engineers can actually have a look at these process piping and drawings with the help of these tablets, right? In layman term, you might have heard of this game called as Pokemon Go. The world went gaga about it. So it basically, with the help of your phones, you are able to see these creatures like, right? But you can also see the garden or the physical environment around you. Your surface is virtual. You are playing the game on your mobile phone, but your environment around is physical. So this is your augmented reality. Now you have something which is called an augmented virtuality, which means you have your virtual environment. You are in a virtual environment, right? But your surface is physical, right? So this is augmented virtuality. And what is virtual reality? Both the environment and the surface is completely virtual, right? So that is. So I am for now currently working with these because I think it's easiest to start with, and to build apps on virtual reality is much more easier than any of these. Right. So I hope this was a clear distinction between the concepts. Now, what is mixed reality? Again, mixed reality is something like this. When you are mixing the environment, so augmented virtuality and augmented reality, they would fall in the purview of the mixed reality. And then what is extended reality? One more term. So anything AR, AV, VR, that is an extended reality. You are extending to the reality, which is here. So a little bit about evolution of VR, but I won't delve deeper into this. The main thing that I want to talk about is, let's say in 2000s, there was a rise of augmented reality and its application. And the virtual reality scene, the company behind it was Oculus Rift, which was, let's say, taken over by Meta or Facebook back then. And now 2020 and beyond, there have been a lot of different companies, that are working with this. So for example, HTC Vive. So if you need a haptic feedback, so then you have, for example, in HTC Vive, you have some of their headsets. So different kind of headsets are now coming into play. HoloLens, which was from Microsoft, that is also a very good gadget for the mixed reality, right? And now Meta is primarily one leading, and also Apple with their glasses. So most of the companies are now moving towards this. So even Facebook, when they changed their name to Meta, if you could delve deeper into that, you'll see that this is again taken from the metaverse kind of thing, right? So the point is, from this point and beyond, there is huge scope, not just in terms of research, but also in terms of the commercial benefits if you are thinking to move digital, right? For example, Singapore as a country, they have a digital twin of the entire country, right? So most of the companies, and there was recently, I think 3 months ago, there was a documentary where they have built a whole digital twin of the entire Titanic, which sank because they took a lot of pictures, and now they can, they have tried to recreate what would have happened on that in April when the Titanic sank, right? So these concepts, they are not just, as I would say, the hype term, but they are really helping the humankind to delve deeper into, for example, whether it's history or science, and to take a lot of meaning out of it. And now, why my personal interest in VR? It was because in one of the projects, I'm supposed to teach this course, which is about wind farms. And honestly speaking, I haven't seen a wind turbine from inside myself, right? So then the question was that, okay, if you want to make your teaching as practical as possible, first of all, you should have an experience to, if not in a real world, in virtual world, that is good enough. And also for the students, because you know that we want to create a workforce for this wind industry, and there is a huge gap in the courses that we are teaching and the skill force that is required. So that is why I thought that, okay, why not to delve deeper into the use of VR? And luckily I found few companies, few solutions which were already there. So if you guys are also interested right now, also you can sign up for this course. This will be taught in end of September. And here I will be using VR to teach some of the O&M strategies. So that is how my interest rose in this particular technology. And as you know, I mean, I don't need to talk much about this, but you know that you can have the first-hand experience of how the technicians are actually doing these. For example, how bolt tightening is done, right? So when you use these MetaQuest and the app that we are using, so while you are tightening the bolt, you'll actually have that feedback. One of the biggest challenges when I was talking to the wind turbine technicians is that they have to stand in an enclosed environment in awkward positions. So you can face that kind of challenge yourself, right? Although it is a very high paid job, but again, there are a lot of challenges which some of you can experience in this virtual environment, right? You have to work in the tight spaces, and then also, let's say, you cannot, at some of the locations, you cannot even, if you are, let's say, 6 feet, so you cannot stand tall. You might have to, with your hunched back, you'll have to work. So those kind of, from the research perspective, what my interest is that I want to reduce the human error for these technicians, because if you go into the research, you'll find that approximately 30 to 40% of the failures that are happening because of human error. And we as scientists or researchers, we are focused more on the health of the wind turbines and not on the health of the wind turbine technicians. So this industry 5.0 that has come into the picture, where human interest is in the center of the loop, that is what I want to, that is like my far-fetched goal, that we want to have these technician trainings so that, when you are fatigued, when you have huge cognitive load, you will not do any kind of maintenance, or you are trained already for that how to behave in that particular kind of a session. But for now, we are using VR only to educate the students, right? So these are some of the advantages what you can have. Now, I can say last year we developed this. I mean, developed as in we bought some licenses of the software. We bought few MetaQuest, one high performance computer, and we hired few companies who are building these kind of environments for us. People who are working with these kind of technologies, they know that Unreal Engine and Unity are the two most favored. But when we want to engage our students, so based upon few of the inputs, I thought that it's very difficult. The learning curve is a little bit steep. So then we end up buying this software, which a lot of people have not heard about. But this is basically a drag and drop kind of software, right? You have your model in Inventor or any kind of 3D model, you just put it and then you can start animating it. So, and this company is now, it is registered in, no, they are a US company, but registered in Jordan. Some kind of thing is happening. So we are working very closely with them. So as I speak, they are building one fully immersive VR experience on Siemens Gamesa, I think 14 megawatt gearless wind turbine as we speak right now. Right, so this is the current status. And then one resource, which again, I stumbled upon during a lot of, surfing of the web pages is this. If I can click on this link. So I'll just go here. So this is actually a company based in Czech Republic. And what they have is, I'll just first of all show you this. So this is called an energy encyclopedia. You can just go over there. And if they have their app on Meta, so you can actually experience a wind turbine for free in there. And it is not just for wind turbine. So here you can see they have a virtual reality extension, not just for wind turbine, but all of the renewable energy sources. For example, here you can see a nuclear power plant. So they have their 3D models, which I was talking to the CEO. And so for the education purposes, they give it for free. So everyone is free to reach out for this free. For example, the wind turbine 3D model, it looks something like this, right? So at a bachelor's level, if I want to give a very, and if I say starting a wind turbine, if I click on this, so it will actually start telling me, and you can experience this all in a fully virtual environment, right? So that is, so I will not run this, but this is one of the resource which I found, and they are targeting right from the bachelor's level. Let's say if I go here, here. So if I go a little bit here, so they also have like a game for the aged 5 to 10 years. So you can actually play that on desktop. So the whole point is that the range of the stakeholders or the student is quite wide. And even this, the CEO, he was pretty open to share all of the resources. So just contact him, you can find his information over here. So my first experience of the virtual reality of a wind turbine was here. So this might not be an accurate representation of the modern wind turbine, but I think it is a fair enough model if we want to give a flavor to some of the students. So that is one thing. And then another company, which is Vinci VR. They are based in, I think, in Denver, and they have worked very closely with Equinor, an energy company in Norway. So they have built a lot of these immersive experiences specifically for the wind turbine. So if I click on this link, so you are taken to their website, right? So here you can see what all they're offering. Now, why? I mean, there are plenty of companies which are doing this stuff, but the point here is that just for $50, which is, I think, let's say 50 Swiss francs or 50 euros, you can buy an experience and you can start. So for me at this point, it was basically, trying different technologies which are affordable and which would give the best experience. So they have shared all of their resources with me for now. And here is their YouTube video if you want to, because those of you who are here, you can experience that in virtual environment. But this is actually, so I have experienced it myself. So you, from this crew support vessel, you go onto the wind turbine, you climb up the wind turbine, and then you do some kind of, maintenance of this, maintenance planning of the wind turbine. And the good part of this virtual environment is that when you are in this crew support vessel, you actually feel that. So this was my first experience. So I was really enthralled with this. So this is the kind of stuff that I'll be teaching in this course. So I have like 4 or 5 different experiences based upon that. They have one experience which is about that how a wind turbine blade is actually manufactured. So that is also a very cool stuff. Right. So currently I'll be using this for these courses. And as I mentioned, the plan for now is to educate the engineers, but over 2 or 3 years, using these softwares that we have purchased, we want to start with our bachelor thesis, master thesis, and then PhD to create these environments where we can actually train the technicians and reduce the human error while they are performing this maintenance planning on the offshore wind. So we are primarily focusing on the offshore wind. So currently I'm also talking to some of the local companies in Norway, and at least one of them has agreed to collaborate with us on this. So I mean, I cannot give you guys VR demo who are online, but again, come to Oslo anytime. I'll be happy. But again, if you want to just see how it looks like, so I've shared the link of this YouTube video where you can just go over there. So for you guys, you're free to do after this whenever you have time, right? So I think that is it from my side. So thank you for your attention, and I'm open to any kind of questions that you have.
Great, thank you very much. Do we have any questions from anyone? I'm checking the chat. I think there was just things about.
So when a situation like this comes, either people have understood everything.
Oh, they don't know what you're talking about. They're waiting to see what's going to come next, maybe.
So it's my colleague. It's a goodwill gesture.
Yeah, but, well, yeah, doesn't it? Did you ask me something?
No, it's not compulsory. Maybe when you try this.
So maybe I have a question. Have you already tried using VR with technicians, or is this still in the future?
No. So currently the one which this company is building for us. So then we are talking to a technician already.
Yeah.
So he is giving the input how it should be. Yeah.
Okay. So what's the general feeling from the technicians? Do they appreciate this? Are they critical?
Yeah.
What's the feedback?
Yeah, at least let's talk in terms of cost savings and also in terms of minimizing the human error, right?
Mhm.
So, I mean, one of the goals that at least I have in my mind is that, okay, let's say when I'm staying right now in St. Gallen and I'm visiting here, right? So I had to, if I was on my own, it would be very difficult, right? But then I was assisted with the technology. It showed me, okay, there are various paths, etc. So that is the same scenario, that if you're familiar with the situation, then you are less prone to make mistakes. That is one aspect of it. So the first thing is we want to give that kind of an experience. Let's say if this is Siemens turbine, you will know what kind of task you have to do. Task number 1, do so that you are minimizing error, you are reducing your time, and at the same time, now comes the part of AI. So we want to build this recommendation system, right? So with the help of these eye tracking devices, we want to see that, okay, your cognitive load is this. It's better to take 5-minute rest, go to the loo. It's not very common.
Yeah.
And then reduce, because if you make a mistake, that is the way, another way of human error reduction. So this thing, they think it is really helpful, but the cons of this is that few people, even when I use this headset for 30 minutes, you really feel that something is happening. And the level of granularity, for example, with this company, WinCVR, they're probably wind manufacturing. When I was using, immediately when I removed it, I had the feeling of a little bit of giddiness. But there another one, another which is on the YouTube, right? That was a pretty immersive and pretty good. When I talk to these guys, so they are like, yeah, because this is a very new one, they are working on this. So there are definitely pros and cons of it, but so technology, when used appropriately, and especially in this case, we have to think how rendering is done, right? If that is good enough, then I think so. People, at least the technicians whom I have spoken to, so they are just 2. My sample space is very less probably. So they are pretty optimistic. At least they are saying that they want to try this stuff, right?
Good to hear.
Yeah, I don't know.
I mean, I think some of the other speakers might have some inputs on that.
So this,
maybe not.
If I can add a little bit, so this reduction of human error, that is more of a research question, that how you can do. So we have people who are working with this mechatronics, and they work with the brain signals. So that is also one kind of, besides eye tracking, what other kind of technologies can measure the cognitive load. So that's the primary thing. And then when we talk of this recommendation system, it's basically, okay, do this, because technician told us that when you are in offshore, so the signal, you cannot rely on the signals, right? If you are stuck, you are stuck.
Yeah.
So then you cannot be, okay, I'll make a call. So there has to be a proper plan that we have to do this, and then, okay, do this. Probably you should do bolt tightening, start with this. Okay, if suppose I forgot, okay, you are doing, so there has to be some kind of an assistive technology. That is like the end goal. I don't know how far we reach. And this coupled with all of these digital twins, which is when you are well informed to do some kind of a specific set, then it is good enough. I remember my first experience changing tires in Norway, because in India, people are there to help you. But here it took me almost an hour. But now it's much easier, because now I am experienced. I already know what steps I should do. So that's the whole point. Without you going to the wind turbine, we are trying to bring that environment to you. You learn, and then you are a little bit more ready. That's the end goal.
I also think for education, it's really interesting. Like, I mean, imagining we've had problems with projects, like research projects we've done, where we've been working with people who haven't worked on wind turbines, right? And so we had one project where a different university was building like a measurement system for wind turbine blades, and we gave them all the specifications, and they built it and then tested it, and then a few years later we said, okay, let's build a bigger version, and they were like, which bigger version? We only built it to be like 1 meter. The whole, we can't scale, like the way it's built isn't scalable to 4 meters. And we were like, well, it said in the specifications from the beginning that it's got to be 4 meters. And we honestly think that the reason that happened is because they didn't have not because they didn't, like, we actually said it to them, but they didn't pick up on it, because they didn't have this feeling of like how big a wind turbine is in their head. And then we were thinking as a group, like, every time we work with new partners, we should take them to a wind turbine and get them experience it. But have we ever done that? No. If we had a virtual environment to do that, possibly we would do that. And so I really like the idea of doing that for education, obviously, but also for getting different disciplines familiarized with wind turbines when you don't have time to access them yourself. I really like that.
Yeah, I also maybe have a question that because you mentioned that this virtual reality is currently built by companies for you, and then what range of student project, for example, bachelor, master, or PhD, what would be the background of students? You're trying to build frameworks with them, or I don't know, going more into the computer science, building this virtual reality. What's your idea on that?
Yeah, I think. So we are not digging too much deeper into this building frameworks and all, right?
Yeah.
So it's more of, that is why the software that we build, that is a plug and play. So you don't need to have, let's say, a background in rendering or in animation. It's basically, if you have done your design course in bachelor's, so you are pretty familiar with Inventor or SolidWorks.
Okay.
So all you do is you take this model, and even not in modeling, because I think if you talk to like big companies like Vestas or Siemens, if there is a good collaboration, and even on Sketchfab, you can actually, there's a cost associated with that. But this Siemens Gamesa, this 14 megawatt, it's for $5,000. You can have a fully 3D model. Yeah. So if you have money, one way is that, because I don't want to use students to make a 3D model from the scratch.
Yeah.
But the point is, okay, from there, you need to have an expert. An expert in this case would be a wind turbine technician. So he will give you kind of, okay, these are the steps that we actually do. It cannot be me, because I've never done that, right?
Yeah.
And then they start building with this. So, and again, depending upon if it is more towards reducing human error, measuring cognitive load, then that is, as I mentioned, it is a more of a research problem. So there, I need somebody who is having this kind of a mechatronics kind of a background, right?
Yeah.
And biomedical engineers. But if it is more of like 2 of my master students, they will do, as I was talking to one of the colleagues here. So we have a physical 5 megawatt something wind turbine in one of the institutes. So we want to make a digital twin with this immersive. So 2 students will work on that.
I see.
And if you are just a bachelor student, then it is just, okay, just do something. Because bachelor students, we have in groups, thesis is in groups. So up to 4 students can work. But master is more individual.
Okay. Yeah.
But then you start getting to have these problems like we've got with so in Task 43 we talk a lot about data standards and sharing and the OEMs are not sharing their CAD models of their blades with anyone, right? But they're not there's many things they're not sharing. And if they're sharing some sort of model for training purposes, then it's bound to be changed or anonymized or somehow generalized or something. But yeah, if more and more companies or organizations want to use models like that, is there a standard that we should be using? What happens when it gets outdated? How do you deal with updating that? Like there could be a chance for sort of defining some baseline for doing training rather than everyone just building up their, because otherwise everyone's just going to build up their own one and we're going to have data silos again like we already have. So that's a really interesting, it seems to be the right time to start doing that now. Interesting. We have a question on the chat from Haijing Liu, but we also have a comment from your colleague Haidar saying that technicians might make incorrect decisions if the VR model lags or displays outdated states of the asset, so real-time synchronization. So yes, I agree with that. And then the question from Haijing is, do you see robotics, such as training students to interact with inspection or maintenance robots, as part of this approach, this educational approach?
Yeah. So firstly, to Haider, I think this concern is with the whole digital twin technology, there has to be the networking and this IoT that has to be fully up to date, right? So that is, but that for now, at least, we are not trying to touch that part, because you cannot touch the whole elephant. You have to go like just the trunk or the tail, tail part of it. But definitely, I see that there is a challenge. But another point, Haider, here is that we don't need to synchronize it on the real time, right? Because when you want to change we want to give them an experience. By experience, I mean, let's say we are in this room. So if an inspection is planned, if you're talking of this time-based maintenance planning, right? If every 2 years, so let's say there will be some kind of a degradation, there will be the gearbox leakage will be there. But on a general setup, if there is a bolt, it will still be there, right? So the physical space won't change. So we don't need the real-time synchronization. We need real-time synchronization in order to get the health status of the wind turbine components, right? And then when should we plan the inspection and maintenance? For that, we need real-time synchronization. But if you want to give an experience in VR to a technician, for that, we don't need, I think. So that is my take on that. But it is always good to have the real-time synchronization. And then Haijang, do you also see robotics such as training students to interact with or maintenance robots? Yeah, I think definitely that would be, again, that is also from the holistic point of view, that makes more sense. But given the limited time and not my expertise robotics, so I'm just staying out of that for now. But happy to collaborate with the guys. And but Sarah, your answer to your question. So it's very difficult. I fully agree to convince companies, especially we have tried to reach to some of the majors here, but it's very difficult. But the only solution that we have found is that, okay, because for the first 5 years, it's the big companies who have all of these contracts, right? So once this warranty period is over, then these small players, they are like, okay, we are a little bit more willing to let you in, because of these local politics. Let's say, if you don't share your knowledge, you don't train the new workforce, right? And then there has to be some kind of mix and match in that situation.
Yeah, I think it would be really nice to have some sort of combined approach, where a group starts to make these things happen together, rather than individuals going and saying, can I do this, can I do this, can I do this, and sort of doing it in together. But let's hear from other people, and then we've got plenty of time for discussion after that.
Yeah.
So thank you again, Arvind, for all these insights, and I hope it was interesting for everyone listening as well. So we're going to go on to the company and research presentation. So we have as I said at the beginning, we have a mix of different things. So Sarah Thomas from the Offshore Wind Academy is going to give an overview more of what in their experience, what do the organizations or companies actually are looking for in terms of training. And then Marcus, who's visiting us come all the way from near Lucerne, to tell us about what the Immersive Reality Centre at the University of Lucerne is doing, but not in wind energy yet. And then Charlie Behan from the Irish Manufacturing Research will talk about something that's been done as part of the EU DigiWind project, where they are working in wind energy on immersive technologies. And then we have a pre-recorded video, or actually an AI recorded video by the sounds of it from this company in Switzerland called Echtzeit, who do offer solutions in immersive technology, including in wind energy. And then actually somebody dropped out, so I ended up filling the gap with myself. I'm talking about a project that we're running, which is not using immersive technology yet, but I think it should be after we finish it. So I'd like to tell you about that. And then we have 10 minutes for questions. So if you've got questions, you can write them in the chat, but we're not going to answer them until the end. So if Sarah, you're ready, then I'll invite you to share your screen and start talking.
Sure thing. I will pull up the presentation now. Okay. All right. Should be able to see it now. If not, hopefully in a few moments. Please let me know if it doesn't appear. But hello, everyone. I'm Sarah Kolmas, and I'm the Director of Training and Education at the Offshore Wind Academy. This is an academy that's based actually in the United States, though I am based in Barcelona, Spain. And that's came together because of a gap that a lot of leaders in the industry noticed across governments, across big companies, that saw that there was quite a bit of training opportunities available for the labor force, like technicians, etc., but not so many opportunities for people that sit behind the desk every day. So this is where this idea of, hey, let's put together an organization that brings in wind experts themselves, especially to train people that mostly are not privy to the privilege of getting these trainings, to create this training academy. So we used to be called the American Offshore Wind Academy, but now we've expanded into the Offshore Wind Academy because we actually noticed that there was a lot of demand from across the world for this kind of training. It's very unique. So today I'm going to be talking about the implementation of these immersive technologies in training and how the industry sees it as useful going forward, as well as a little bit of context for the workforce. So this should set the context going forward for the rest of the presentation, or the rest of the presentations coming up. Right. So as I said, we are an academy that was born out of this desire from many players of the industry to have some sort of centralized one hub for knowledge and networking. So I just threw a couple of different logos here that you'll probably recognize. These are our partners. These are people who help us give training courses. These are people who attend our courses. These are people who provide us with content. And we have many different kinds of training courses available. So you can take a look at our website to see all the different kinds that we have available. But within just 1.5 years, we've already trained over 450 people. So it's quite a in-demand type of training. So enough about the academy. Let's talk a little bit more about workforce in general. I have this small graphic here from Wind Europe, which is as I'm sure everyone here knows, which is the biggest working association group for wind in Europe. And it has the dark blue for onshore and the light blue for offshore wind. And this is the installed capacity expected each year. So it's not cumulative, it's actually in each year that they think they're going to be installing these projects. So as we see that there's this rapid growth, it really hits around this year where projects are going to be starting to really take off. A lot more gigawatts being added because we have the EU Green Deal, and there's a lot of countries that have very high gigawatt targets for 2030, 2045, 2050, etc. And obviously, the equation, I'm sure, would make sense is that if there's more projects, you need to hire more people. You need to hire more people to service the wind farm. You need to hire more people within the offices to keep an eye on things, to design, to quality check, etc. And obviously, as the workforce is getting bigger and bigger, there's tons of numbers out there. I've seen hundreds of thousands more that we're going to be needing in the next couple of years, that we're going to be needing more training. And there's only so many training centers that exist in the world. Offshore Wind Academy being one of them, but there's several more across the world and across Europe. But this is also where we think that VR and AR could be quite interesting to help increase the capabilities of training. At the Academy, we had a small list, or a large list, let's say. We pulled together a large list, and we found that there's about 200 or so job titles that are associated with offshore wind. And I went through and I pulled through all the jobs and decided which ones I think would be benefiting from digital twin, AR, VR, and actually 60% of all offshore wind jobs could benefit from the use of AR, VR, and digital twin within their daily jobs. If you add an AR and machine learning, that number goes up even higher. So this is great. This is a wonderful technology that we see is very useful for the future. But if you go and talk to companies, if you go and talk to workers, and if you consult many different reports from DMV, GL, for example, it's very clear that there's quite a large gap for digital skills in the workforce, whether it's SHAM, whether it's understanding what is AR and VR. Here we seem to have known, that's great, but not everyone does. And we pull a lot of workers over from oil and gas because we need to fill these gaps right now. For example, there's this project for like the EU skill or the green passport in the UK to upskill people who worked in oil and gas into offshore wind because they're very similar industries, but they're also quite older, let's say, so they don't have as many of these kinds of technologies involved. So we really are seeing this gap that most people do not know how to use AI, do not know how to use machine learning, don't have the basic STEM skills, etc. So we really do need to get training people in these technologies. Just as what are some ways that we see that it could be useful for training technicians, for training people in the offices, for training quality workers, for training safety officers, etc. There's so many different ways. For example, we have these simulations of complicated designs and procedures. One of the biggest things that we've heard from the industry is that the wind industry is extremely specific. You can't just pull people that work in other unions from other industries because wind is so unique in the way that the blades need to be handled in a certain way, that the pile drive needs to go in a certain way, etc. So having these kinds of VR opportunities to be able to simulate those complicated procedures that are not possible in a classroom would be super advantageous. It also would help that when we're trying to design the wind turbines, this is also great for checking to make sure that things fit together well. For example, from an aero perspective or from a systems design, you put together the drivetrain and the nacelle and you realize that, hey, it clashes with the bed plate. You normally wouldn't know that until you go to design it, but in VR, it's always possible to find that out faster. There's also the importance of being able to simulate emergency responses. For example, this photo right here. We do these in classrooms, which definitely should not be removed, but it's good to be able to repeat them with more frequency in a virtual environment. You also can use simulation of environmental impacts. So for people who are doing environmental permitting, they can create these sort of VR, AR environments to be able to simulate, hey, like if we put a wind turbine here, based on what we know about the surrounding zone, here's how the environment might interact. So we'll give them some more foresight into what could be happening to be able to make decisions on permitting and cable laying, etc. Another one that I think would be really interesting that we were talking about in my previous company before, I worked in LM Wind Power for a little bit in GE Vernova, is that you can actually, for newer technicians, have AR when you're on the manufacturing floor and you're trying to do complicated procedures. And it has the maintenance manuals right there to be able to give you a sense of, okay, next step is this. Now I follow this step. If it looks like this, it's not so good. And also to lay out where the next plies for fiberglass might go, for example. So this will reduce the amount of human error that appears and increase the quality of the product. Otherwise, there was this really cool training center I saw when I was at Wind Europe that they put you inside this lovely little cube with a VR headset. And for this case, it's for training maritime operators. But in general, you can use it for anyone that needs to go learn the layout of the website. Maybe they're going to go work on the substation. Maybe they're training to become a maritime operator, etc. So you can put them in the virtual environment of the site so they can learn where everything is, good for inspection planning, etc. And lastly, for fault handling. So this either, again, can be like actually happening, like in this overlays, or it can be for training technicians. And for example, if one turbine provider finds that they have more problems in their yaw drives, for example, they can make sure that their focus is going to be like on their technician trainings for yaw procedures. Hey, we've seen a lot of the variable frequency drives failing, so let's make sure that our technicians know how to handle that through this training in this virtual environment. So these are just a couple of ways. There's still so many more ways, but we think that these are the most exciting ways as an industry to start to train people using VR and AR. I think I'm coming close to the time, so I'll just try to move a little bit faster. But if you're going to be creating trainings for people. The most important thing is this process that we follow here in the academy, which is making sure that you assess the stakeholders that are going to be taking your trainings, figuring out what they need, what are their gaps, where are they really seeing like the biggest problems in order to be able to properly execute their job. We work a lot with the academy, always in tandem with industry partners. So we make sure that we get the opinion of the industry throughout this whole process with identifying stakeholders we might be missing, what trends are they seeing, what trends are we seeing. It's a good chance to come together and not only do this assessment, but also to co-design curriculum. So we always make sure that we're going out there to find new tools. For example, I'm learning a lot watching this presentation, which is great. And making sure that the curriculums that we are designing are actually covering those gaps that the industry does see as coming up. And always making sure that you have that feedback loop open, whether it's the attendees, whether it's the people giving the instruction, and whether it's even just the facilities coordinators, anyone who's involved, to make sure that you keep getting better and better, and then eventually getting those industry recognized credentials, because we find that if you offer trainings without these kinds of certifications like ISO, ANSI, etc., that you will have less trainees coming through, because there's so many already trainings that they need, that it's important to have the certification so that they can really prove that they know the operations inside and out. Otherwise, in terms of just what we offer right now these live online courses, always with a real industry expert teaching them, not us at the academy. This one is the robotics and autonomous course. Hopefully in the future could be VR classroom. I think that would be amazing. We also do in-person workshops in actual industry facilities, like in blade testing facilities in Boston. We're going to be doing one at the generator manufacturing center in GE coming up in October. And in the future, we're going to be offering these online self-paced courses that allow people anywhere to be able to access them. And for companies that want to, for example, reboot their workforce's digital skills on an annual basis, this is also possible. So just to wrap up here, I also have this, it's funny, I also saw that Dr. Keprate has a course, an O&M course coming up at the end of September. So do we. So hopefully maybe we can pair together in the future on this. We have GE, Vernova, and Ørsted going to be teaching this course. They're people who, like myself, have worked in the offices, but have also climbed wind turbines. Hopefully, it would be nice. I would like to invite all of you for a 20% discount to come to the course and hopefully bring your immersive technologies perspective. Otherwise, please take a look at our catalog. Let us know if you feel like something is missing, and we're happy to partner at any points with you to do podcasts, to do courses, anything. So my contact details will be in the slide going forward. And I think I'm out of time. So thank you very much, and hopefully this sets the context moving forward for what the industry is looking for in the workforce.
Brilliant, thank you. Just in general, Task 43 is very interested in talking to you more. I'll write you an email later if we don't have time to discuss it. I think that also gives us some really nice context for the rest of the presentations. So again, questions in the chat, and I'll just move on to the next speaker now, who is Marcus. How do you want to just do it on my computer?
I think it's on yours, otherwise.
I have it on my computer, yeah. You can